Hi everyone. In this series of videos we're going to look at factorization of polynomials. In particular, we're mainly focusing on cubic polynomials, but the same things would apply for quartic polynomials, which have a degree of 4, and other higher order or higher degree polynomials. So let's just jump straight into it. Now, what we're going to do in this question is verify that when this polynomial p of x is divided by x minus 2, that the remainder is 25. Okay, so first of all, let's just do that using long division. So let's go and do x cubed plus 3x squared plus 2x plus 1. We're going to divide that by x minus 2. Alright, so following the process of long division, first we divide. So x cubed divided by x is x squared. Multiply x squared by x minus 2. You get x cubed minus 2x squared. Subtract these terms. That becomes 0. You get 3x squared minus negative 2x squared is positive 5x squared. Bring this down. And 2x, and we repeat. So 5x squared divided by x is 5x. 5x times x minus 2 is 5x squared minus 10x. Subtract these terms. 5x squared minus 5x squared is 0. 2x minus negative 10x is plus 12x. Bring this plus 1 down. And repeat. So 12x divided by x is 12. 12 times x is 12x. And 12 times negative 2 is minus 24. Finally, subtract these. So 12x minus 12x is 0. 1 minus negative 24 is, in fact, 25. Okay, so our remainder is 25. Now, for no particular reason at all, let's work out p of 2. Okay, sure, why not? Let's do that. So p of 2, just replace all these x's in our polynomial with 2, and you'll get 2 cubed plus 3 times 2 squared plus 2 times 2 plus 1. 2 cubed is 8. 2 squared is 4, so 3 times 4 is 12. 2 times 2 is 4 plus 1, and yep, oh, would you look at that? We get the same number as the remainder when we divide them. Isn't that interesting? Can you maybe see a connection between the number that we put into this polynomial and the factor that we divide the polynomial by? Maybe. Oh well, let's do another question. So, verify when this polynomial is divided by x plus 1, the remainder is 2. Okay, let's do long division. You can always get lots of practice doing long division. Okay, so x, oops, I've made a terrible mistake. I have not included the x term in my division. That's better. Okay, so x cubed divided by x is x squared. X squared times x plus 1. X cubed plus x squared. Subtract these. X cubed minus x cubed is 0. Negative 2x squared minus x squared is minus 3x squared. Bring the 0x down. Repeat. Negative 3x squared divided by x is minus 3x. Negative 3x times x is negative 3x squared, and negative 3x times 1 is minus 3x. Subtract these terms. Negative 3x squared minus negative 3x squared becomes 0 as always. 0x minus negative 3x is positive 3x. Bring the 5 down. Repeat. 3x divided by x is 3. 3 times x is 3x. 3 times 1 is 3. Subtract these. 3x minus 3x is 0. 5 minus 3, positive 2. There we go. Okay, so the remainder is 2. Let's also, for no reason at all in particular, substitute x is negative 1 into our polynomial. So do p of negative 1. What do we get? what am I doing there? P of -1 equals, okay, so replace all the x's with -1, so get -1 cubed minus 2 times -1 squared plus 5. Okay, -1 cubed is -1. -1 squared is 1 times -2 is -2 and plus 5. So we got -1 minus 2, which is -3. -3 plus 5 is 2. Or would you look at that? Again, the numbers have turned out to be the same. And is there a connection between the number we're substituting into our polynomial and this factor that we're putting in here? Almost. Okay, this is a +1. We're substituting in a -1. In the previous question, this is a -2, whereas we've substituted in a +2. Okay, so there is some connection here between the factor that we're dividing with and the remainder and also this number that we put into our polynomial. And in fact, this is a property of division of polynomials, okay, and we give it a name. It's called the remainder theorem. Okay, so the remainder theorem states that when some polynomial p of x is divided by some linear factor, these two symbols here are Greek symbols. This is beta and this is alpha. Okay, it's from the Greek alphabet. They're just coefficients. Okay, don't worry too much about the actual symbols. Okay, so when we divide a polynomial by some linear factor, something x plus something, the remainder is going to be what you get when you substitute this quantity here, negative alpha over beta, into your polynomial. Okay, so here are the two examples that we just showed you. Now just be aware that this is 1x minus 2 and this is 1x plus 1. Okay, so if that's beta and that's alpha, okay, so what this remainder theorem states is that if I substitute for this first one negative alpha over beta, so that is negative 2 over 1, which is just 2. If I substitute 2 into my polynomial, I would get the remainder once I evaluate it. Okay, same thing for the next one. Okay, beta in this case is 1, alpha is also 1. So if I substitute negative alpha over beta, which is just negative 1 over 1, which is negative 1, if I substitute that into my polynomial, it would give me the remainder. Okay, what about this third one? We haven't seen this one yet. So again, this number, this number at the front is beta. This number as a constant is alpha. So if I substitute negative alpha over beta, which in this case is negative 3 over 2, which we just leave as negative 3 over 2, if I substitute that into my polynomial, it would give me the remainder when I divide my polynomial by this. Okay, this is the remainder theorem. Okay, and it gives you an easy way to check for the remainder without going through the whole long division process. Okay, and that makes things a bit easier for us. Cool. Right, let's see this example one more time. So we're going to use the remainder theorem to find the remainder when we divide this polynomial p of x by 2x plus 3. Okay, so first of all, let's figure out what value we are substituting into our polynomial. Okay, so we're substituting this negative alpha over beta business. So remember, this number that multiplies the x is the beta. This number you add at the end is alpha. Just be aware that alpha could be negative. Beta could also technically be a negative as well. So in this case, we're going to substitute p of negative alpha over beta, which in this case is p of negative 3 on 2. And you'll notice that's just exactly the same thing that we had in the previous slide. Okay, so let's do that. P of negative 3 on 2. Alright, so that just means substitute x for negative 3 on 2. So for our first term, we're going to have 4 times negative 3 on 2 cubed plus negative 3 on 2 squared minus 3 times, negative 3 on 2, plus 2. Now you could already probably see this is going to give us a bit of a headache because everything's in terms of fraction and we're cubing and squaring fractions and all this nonsense. But it's good practice to deal with fractions sometimes, okay? We can't always play in la-la land where we just deal with positive whole numbers. So we have to deal with fractions sometimes, so let's just do it. Okay, so first I'm just going to cube and square these things before I start multiplying it by their coefficients. So we're going to still have 4 times. Alright, negative 3 cubed. That's negative 3 times negative 3 times negative 3, negative 27. Over 2 cubed, which is 8. Alright, let's do plus. So negative 3 squared is negative 3 times negative 3. It's 9. And 2 squared is 4, so we get 9 over 4. Here I've got, I'll expand this one. So I've got negative 3 times negative 3 over 2. So just do the negative 3 times the numerator. So negative 3 times negative 3 is positive 9. So our fraction becomes positive. And our denominator doesn't change. So it's still just over 2. And finally we've got this plus 2 business at the end. Okay, let's keep going. So notice what I've got here is a 4 times something over 8. And we can actually reduce this fraction, we can simplify it a bit, because we can pretend the negative 27 isn't there, and just do 4 over 8. That would reduce to 1 over 2. Then we can introduce the negative 27 back in, and so this would actually just become negative 27 over 2. Okay. You could, of course, do 4 times negative 27 and work that out. What would that be? 2, 4, 6, 8, 7, 14, 21, 28, 108, something like that? I don't know. But it's just better to reduce it straight away. Okay, plus 9 on 4, plus 9 on 2. And I'm going to change this 2 into a fraction with a denominator of 4, because we're eventually going to have to add all these fractions together. So if I just do that in this step, we're going to get 2 is going to become 8 over 4, like that. Okay. Now I've got to change all the other fractions to denominators of 4 as well. So I just multiply both top and bottom by 2. So in the first fraction I get negative 54 over 4 plus 9 over 4 plus, same thing for this fraction here, 9 over 2 becomes 18 over 4 plus 8 over 4. Okay, now that they're all over 4, we know our final answer will be over 4 as well. And now you just have to add the numerators together. So negative 54 plus 9 plus 18 plus 8 should give you negative 19. Okay, I did that quickly because I've already done this question. So don't expect to add things up that quickly, just take your own time. Okay, so what that tells us is that when we divide this polynomial by this factor here, we should get a remainder of negative 19 over 4. Okay, can we verify this using long division? Well, let's go and try and do that. So in our previous videos, we haven't divided any polynomials by a linear factor that has a coefficient other than 1. Okay, most of the time when we've been doing our divisions, it's just x plus 3, x minus 2, x plus 1, stuff like that. Here I've got 2x plus 3, okay? But the process doesn't change. The only thing that's going to happen is you're going to end up with some ugly fractions to deal with. But we can deal with them, okay? They're not scary, just take your time with them, okay? Get some practice with them. So, let's do this as a long division. 4x cubed plus x squared minus 3x plus 2. And we're dividing this by 2x plus 3. Okay. So, first step, divide 4x cubed by 2x. You should get 2x squared. Next, multiply 2x squared by 2x plus 3. You should get 4x cubed back. And 2x squared plus 3 is 6x squared. Subtract. 4x cubed minus 4x cubed is 0, just like always. And x squared minus 6x squared is negative 5x squared. bring the next term down, minus 3x. Repeat, so negative 5x squared divided by 2x. Well, the x's will cancel out, leaving us just with an x. But we've got negative 5 over 2, which we can just leave as a fraction. Negative 5 over 2 times x. Multiply negative 5 over 2x by 2x plus 3, so that would become negative 5x squared, and negative 5 over 2x times 3 would be negative 15 over 2x. Okay. Next step would be to subtract. Negative 5x squared minus negative 5x squared, cancel out, becomes 0, just like always. Negative 3x minus negative 15 over 2x. Now we've got to start dealing with pesky fractions. So let's change the 3 into a fraction with a denominator of 2. 3 becomes 6 over 2. Okay, so really I've got negative 6 over 2 minus negative 15 over 2, or if you prefer, negative 6 over 2 plus 15 over 2, you get positive 9 over 2x. Okay? Bring down the 2. Repeat. So, divide 9 over 2x by 2x. Well, the x's are cancelled out. It's gone now. We've got 9 over 2 divided by another 2. And when that happens, you just multiply that number here with the denominator of your fraction. Okay, so we're dividing it by another 2, which turns it into 9 over 4. Multiply 9 over 4 times 2x. We should just get 9 over 2x back. And 9 over 4 times 3, we just multiply the 9 and the 3 and you get 27. So 27 over 4. Finally, we subtract 9 over 2x minus 9 over 2x, cancels out, becomes 0. 2 minus 27 over 4. Okay, again, we have to deal with this fraction subtraction. So we're going to change the 2 into a fraction with a denominator of 4. That 2 would become 8 over 4. So really, we've got 8 over 4. Just put that to the side here so you can see. 8 over 4 minus 27 over 4. So just do 8 minus 27, and you should get negative 19 over 4. There's our remainder, and it's equal to what we had over here. So, unfortunately, sometimes you're going to have to deal with fractions. Okay, it's just a fact of life. It's a fact of what you have to do in maths. Don't always expect nice whole numbers to work with. You will have to deal with fractions, and they will make things longer, okay, and more tedious. But don't shy away from them. Get practice with them. Otherwise, you'll be scared every time fractions pop up and you'll go crazy. Okay, so make sure you don't shy away from fraction problems. Anyway, that's the remainder theorem. Okay, the main part is identifying this beta and alpha business with this factor that you are using to divide, and then substituting those alpha and beta into this polynomial in the form of negative alpha over beta. Okay, for monic linear terms like x minus 3 and x plus 2, you're going to be substituting just the opposite of the number that you see there. So it would just be p of 3, and this one would be p of negative 2. But for more complex linear factors such as this, you have to use a fraction. Okay? All right, let's do one last question. Okay, this one's slightly different. So it says, when p of x, which is this polynomial here, is divided by x minus 2, the remainder is 4. Find the value of a. Okay, so it's telling us the remainder to begin with. Okay, and if we use the remainder theorem, we know that if I do p of 2, okay, remember to substitute the linear monic factor, we just change the sign of this number that we've got here and substitute that in. So we're substituting p of 2 into here, and we know that that is going to equal the remainder, which is 4. So let's do that, write it all out. P of 2 is 2 cubes plus 2 times 2 plus a, and we know in advance that that's going to equal 4. And our job here is to work out the value of a. So here I've got 8 plus 4 plus a equals 4. And if you subtract 4 and 8 to the other side, so subtract 12 both sides, you end up getting a equals negative 8. Okay, there you go. Okay, problem solved. So we've used the remainder theorem to solve a slightly different kind of problem where we have this unknown value in the polynomial, but we already know what the remainder is. Okay, and of course we can verify this answer with long division. All we have to do is do x cubed plus 0x squared plus 2x minus 8, and we have to divide that by x minus 2. I'm not going to do that here because we've already spent so much time on this video, but you can verify that yourself and see that you do indeed end up with a remainder of 4. Alright, that's it. We'll stop there. I'll see you next time.